Good morning, everyone. I want to welcome you to another motivated statistics class. Of course, we're starting a new topic today. You will observe that I decided not to give out new assignment this week because I want you to, for those of you who want to participate in makeup, so that you're going to have enough time to get yourself prepared, you know. Um, and don't forget, I've already released the solution to the midterm 1 and 2. You can check that on Canvas. So today, like I said, we're starting a new topic, and this is called discrimination and classification. In the hotline, I think I will be able to achieve the first three, and Friday will be dedicated to 4 and 5. So, one, we're actually going to learn how we classify two populations. Okay, I'm going to walk you through the overview of the problem of classification. And of course, because we're using model to do classification, and our model is not perfect, so definitely there's going to be some kind of misclassification. So, and every misclassification come with a cost. So I'm going to walk you through the cost of misclassification. Then from there, I'm going to talk about two multivariate norma, because we believe that if we want to do classification, a particular class follow a particular distribution. So I'm going to walk you through when equal covariance is assumed, like equal covariance structure is assumed for the groups, and when unequal covariance is also assumed. And after that, I'm going to walk you through how do we know if the model that we are using to classify has done a great job. And that's what we call evaluating the classification. So I'm actually going to walk you through some misclassification measures. And after that, then I'm going to go into what we call the IDA. The IDA is one of the classifiers. We call that linear discriminant analysis. So, of course, on Friday, the focus is going to be on the objective 4 and 5. Okay, so I need you to pay attention to this. I'm going to start with the purpose of discrimination and classification. I used to tell people around me, there's a variations in the world. Okay, we got variation. Okay, we got variations in the world, and because of that variations, the world is stochastic in nature. We live in a probabilistic space. Now, because of the variations that occurs in the world, we are not necessarily going to be in the same class. So different group of, we actually, belong to different groups. Now, how do we actually, separate, the distinct set of objects, and how do we allocate new object to group? It's just like somebody approach a bank for a loan, and of course the decision may be to award the loan or not to offer the loan based on some predators. Now, banks have done that in the past where they award a loan and the customer defaults. Okay. Maybe the bank actually thought they were never going to default and they default. That's a misclassification. So the bank want to use the data they have right now. They will first start with discrimination. So discrimination is not the same as classification. The discrimination just has to do with separating the distinct set of objects that we have right now. Okay, just like the bank trying to separate based on the data set they have, trying to separate customers, by default or no default, based on historical history. And of course, they build a model on that. If they build a model on the existing data, then we're actually going to use that model for classification. That is classifying a new customer that has approached the bank for a loan. So if you want to classify a new observation, okay, that's what we call classification. Okay, you want to allocate new observation to a particular predefined group. That's what we call classification. But we don't go to classification without passing through discrimination. So it's going to be a discrimination force. What are you discriminating? When you are discriminating, you don't make use of new observations. So you base your analysis on the data set, that you currently have. So there are two major goals, just like what I said. Okay. And the goal is sequential. Like I said, you start with discrimination, then after that, then you're gonna go for classification. So classification is the same as allocation, which means you're actually allocating, new observation to a particular class. I've used an example of a bank. We got so many situations in real life where we actually want to solve a classification problem. If you want to talk about disease diagnosis, if you want to talk about whether economy is going to boom or going to recession, okay, and so on, like that. Okay, up to whether customer that visits your website is going to purchase products or not. Now, I'm going to start. I want to believe that a community will start from two people. So if I want to talk about groups, okay, at least we're going to start from two. Okay, so right now, I want to talk about classifying two populations. Now, in the classification problem, I want to believe the response variable that I call the outcome variable is categorical. And of course, in addition to the response variable, you're actually going to have some features that I call predictors. If you approach a bank for a loan, the bank is not just going to give you a loan immediately. They have to look into maybe your credit history. They look at your age, they look at your income, and so on like that. Those form the features that I talk about. Now, when you take a look at this now, let's X is now the features, X1, X2 up to XP. Okay. Now, we believe that for each population, okay, there exists a probability density function, okay, the probability density function that actually is centered on this predictor. And that's why you see F1X and F2X. Now, this is a problem that we actually want to solve. Maybe probably giving the balance or your income or maybe your credit history, can we classify you into what a default group or a not default group? That's exactly what we mean here. Okay, or based on a particular medical predator, can we classify patient? I mean, can we classify, um, yeah, patient into either having a disease or not? Now, if we want to do that, I want to believe there's going to be a classification rule. Okay, so like I said, we want to find some classification rule to determine whether a realization should be assigned to a population pi 1 or pi 2. So we're using pi 1 and pi 2 to denote, the two groups that we are considering here. Okay, now I need you to pay attention because there's going to be a rule. Then how do we visualize the particular rule, the classification rule? Now, we're going to consider omega that we call a sample space. What do I mean by a sample space? It's everything. Sample space means collection of all possible outcome. Okay. Now, we mean all possible values of x. That's what we mean. All possible values of x. Okay. Now we actually going to have, arrow one and arrow two, and I need you to pay attention. The arrow one and the arrow two, when I find the union, I'm actually referring to all possible values of x. I'm going to say that again. Arrow one union, of course, union in math, actually means, collection of, elements in a particular set and the elements in the other set. Now, in such a way that here I'm trying to say R1 is a subset of the omega. Okay, so and that subset of the omega for which we classify, a particular predator into group one, and of course, R2 because of the fact that when I had R1 to R2, I have omega. Omega is a possibility. So if I want to figure out R2, then R2 is just going to be possibility minus the R1. Now, in that would be the subset of, the omega for which we actually going to classify it into group two. Now, this is actually the picture, if you want to visualize that. Okay, you're going to have an opportunity to see we got two different regions, which means based on the values of predators, the observations are being classified into two regions. Okay, if you can read more, this is it's on the textbook. Okay, now and with that one that I just show you right now is based on two variables. Okay, two variables, could be more than that. Now, because of the fact that Judge Box, said, and I quote, that all models are wrong, but some are useful, we find ourselves in a world where we want to depict reality, we want to speak the mind of nature. Of course, here we want to have a successful classification using a model, and of course, the fact that a model does not give exact characterization of reality, there's always going to be a gap. Now, in classification, okay, since we've already acknowledged the fact that our model is not never going to have a perfect classification. There's a room for error. Now, what we're going to do here is there a way we can find the probability of misclassification? So the probability of misclassification is going to exist. Okay. Now, let me tell you this. The cost that comes with classification, okay, is actually, vary depending on the context. Imagine a military, they maybe uh they have a wrong assumption of their opponent that may be deadly. They have a wrong assumption of the opponent that may be deadly. Okay. And of course, situation whereby somebody who have a disease, or particularly maybe during the epidemics, and the equipment was not able to detect that the person have a disease, that may be disastrous. Or situation whereby a court, wrongly sentence, an innocent person, okay, that's going to come with a very huge cost. Okay, now, you know what I want to talk about now? Okay, I want to talk about the conditional probability when you see two given one. Okay, so which means we have classifying object as pi 2 when it's supposed to be in group one. It's possible. Maybe somebody the bank thought is not going to default, and the person eventually defaults. So what we want to know the percentage of that kind of occurrences. When I say the percentage of that kind of occurrences, that is why we want to find probability. So when you hear probability, don't be scared. Probability is just talking about, I want to figure out, the percentage of such occurrences. Okay, so what is the probability? An object that was classified to be in group two, and then the nature, because nature knows the truth, okay, it's supposed to be in group one. Okay, so this is so it is the same thing as the probability of S lies, that particular notation means lies in region two. Okay, you believe that it lies in region two, but given that it's supposed to be in group one. Now, what I'm going to do here, oh my God, what I'm actually doing here is to perform an antiderivative on the density function of the first group. Okay, and I'm going to use um the what I'm going to use in the integral, the bound is actually going to be R2. So pay attention to that. Similarly, you can also have the other kind of classification, where somebody that's supposed to be in group two is now being classified, as being in group one. And of course, we can figure out the probability associated with that. And to figure out probability associated with that, of course, we're going to seek redress or under a curve, because the f of s here is probability function of a continuous random variable. So when you want to you want to have a probabilistic computation of for a random variable that is continuous in nature, of course you actually going to perform an antiderivative. Is there any questions so far? Is there any questions so far? Okay, now I want to give you an opportunity to visualize the probability of misclassification. You can actually see a curve. You can see f of 1s, right? Because the f of 1s, the f of 2s, they are probability density functions. Because they are probability function of a continuous random variable, we're going to be talking about a curve, a density curve. Okay, now you can see the f of x1, you can see the f of x2, and of course, here we are trying to locate the probability of misclassification within this particular framework. Now, there are two forms of the probability of misclassification. You can see the region classified as pi 1 and region classified as pi 2. The fact that the two curves, if you take a look at the two curves, they overlap. Overlapping, whenever there's overlapping of curves, there's going to be misclassification. But situation where the curve don't overlap at all, If the curve don't overlap, okay, then you are ruling out probability of misclassification. But let me tell you, I don't think that is going to happen under its own. There's always going to be classification, I mean, misclassification, because we're using model, and model is never going to give us an exact characterization of reality. Okay, I need you to pay attention. Before I start, I want to believe a bank that is going to that actually that have been giving loans, they have history of customer paying back and customers not paying back. Okay. Do you know that before they're going to base their decision on predators? For instance, before they're going to base their decision on maybe probably your balance on the account, your income, your credit score, and so on like that, before they actually going to look at that, they will need to first consider the state of nature before data collection, before I look into the predators, before I look into your credit score, before I look into your age, before I look into your income. Can I actually just look at my data frame and see what is the percentage of the numbers of time we have made correct decision in this bank in terms of giving out loan, and what do we also have a record of the numbers of times we have misclassified. Now, when you want to do that, we're talking about prior probability. When I say prior probability, the prior probability is the probability of the state of nature before you cite predator, before you look into predator at all. What is the probability of the state of nature? And that's what I'm giving you here. Now take a look. There are four possibility. There are going to be four possibility. Number one of that, they actually have a record of the numbers of time they've classified, objects into group one correctly. The numbers of time they've done that for group two. The numbers of time they've misclassified group one for group two and group two for group one. That is exactly what I'm showing now. So where you see 1-1, where you see 1-1, that's a correct decision they've made. Okay, the nature said this customer is actually going to default, and they were able to know that ahead of time. And two, the nature, say that this customer is not going to default, and they know that ahead of time. But when you see 2-1 and 1-2, that is where they made incorrect decision. Now, I need you to pay attention. So what you are seeing, if you take a look at, this, the one that is prior. Okay, I'm actually going to show you is this one here. That is the one that is prior. Like, what is the percentage of the numbers of time that customer default in our bank? That in that regard, I'm not referring to predator. I'm not referring to your income. I'm not referring to what is the percentage of time the customer did not default. That is what P1 and P2 represent. And there's going to be a constraint on the P1 and P2. When I add them together, it should give me 1. That 1 means 100%. The 100% of my customers that have actually applied for loan. Okay, some of them default, some of them do not. Now, after that, I'm now going to look into what we normally refer to as a posterior. When I say posterior, I want to update my belief. The initial belief that I have was in terms of prior. But after seeing your income, after seeing your balance, after observing your predator, okay, and I want to update my belief. So what that is, so if you take a look at if you take a look at what we're doing here, okay, we are multiplying. Okay, let me show you something. Please pay attention. Okay, now when you take a look at this is more or less like having a likelihood. Well, why do I call that likelihood? Because that involves predator X. Okay, that involves predator X. Okay, this one, the first one is saying, okay, when I've seen predator S, I classify that into group one. Okay, when I see predator S, I classify somebody into type two. When I see that, I classify, then this that you have here now, they are now the priors. So likelihood multiply by the priors, that will give you posterior. Okay, this is what I mean by posterior. Okay, posterior. Okay, the posterior is going to be a combination of a prior and a likelihood. Now, if I want to write that in a short form, okay, if I want to write that in a short form, I'm actually going to write this. P11, P1, P22, P2, P2, P2 giving 1, P1, P1 giving 2, P2. Take a look at that. That's how I'm going to write that. Okay, now I want to take us into classification table and misclassification cost. Now, when you look into the many reward, the costs of misclassifications are not equal. Okay, the cost where court made a mistake. I want to believe court want to make sure innocent person is not sent to jail. There's another error they can commit. Okay, somebody who convicted or somebody who committed a crime, who nature knows that this person really committed a crime. There's possibility the court could discharge him unacquitted. And that's why I used to tell my $5. I used to tell them, we have criminals that live around us. Be careful because of the error committed by the court. So the cause of misclassification in a court system is different from the cause of misclassification in military. Okay, it's different from the cause of misclassification in medical diagnosis, and it's different from the cause of misclassification when you believe customer is going to buy stock and customer don't buy. Now we're going to have a table for that. This is the table. The one side of the table is what we call the truth. Why do I say truth? Oh, that is what the nature says. Nature always knows the truth. Nature always know the truth. Do you know what we are trying to do? What we are trying to do is to speak the mind of the nature. At times, we don't speak the mind of the nature correctly. Now, this is what we did. This is the classifier now. Okay, this is classifier now. Okay, the nature actually saying that is group one. And if we classify to group one, okay, then there is no cause because we did not do a misclassification here. When you classify correctly, there's going to be zero cause because you've done a great job. Now, when you take a look at the nature said, oh, that guy should be in group two, and you classify the guy as group two, then that will come with no cause. Correct classification do not come with any cause. But what is going to come with a cause now is actually misclassification, and which is what we have here. This is the cause of classifying somebody into group two, and that person by nature should be in group one. And this guy here is a cause of classifying somebody into group one, and by nature, it should be in group two. So definitely you are never going to have zero. I didn't put any value. It depends. Okay, it depends. Okay, but you know what? Because we live in a stochastic environment, because we live in a probabilistic space, then we normally want to figure out what would be the average of misclassification costs. And that is what I want to figure out right now. What will be the average? So the average is what I call the expected cost of misclassification. So the expected, of course, in you remember in lower level statistics, where if I have a random variable s, and maybe s is a discrete random variable, and maybe for this x, there's a probability associated with this value of s, there's another probability associated with that value of x. If I want to get the expectation, I will multiply the value by the probability that I'm going to add them up. That is what I'm doing here. Please pay attention. That is exactly what we are applying here. Okay, you see what we're applying here, but with a little different. What kind of probability are we going to multiply with a cos? Is it just going to be prior or posterior? But it's going to be posterior. That is why, take a look at this now. Do you see that? That's a posterior, which is a combination of the likelihood and the prior. The same thing here. Take a look at that. And where do they come from? Where do they come from? Okay, where do they come from? The P1, the P2, the P1 given, I think I showed you before, they actually come from here. Look at that. They come from there. Now I want to move right now. Now that you now understand how to figure out the expected value of misclassification cost, then can we have a misclassification rule? Now, whenever you are setting up a misclassification rule, you need to set it up in a way to minimize the average cost of misclassification. I'm going to say that again. When you're trying to set up, okay, a classification rule, when I say classification rule, the rule of allocation, the rule of allocating new observation into group, then you have to put into consideration, minimizing the expected classification cost. Now, and that is what you see. To classify, so which means there's going to be inequality, of course. We need to if we don't belong to the same group, then you are nullifying equality, and that's why there's going to be inequality. So right now, to classify into R1, now I'm going to do the likelihood ratio. Please pay attention. I'm going to do the ratio of the probability density functions for the two groups, which is the one you're actually seeing here. Take a look at that now. Okay, you see to be classified into region 1, to group 1. So that ratio must be greater or equal to this. When you take a look at that, what are we using there? We are only using the probability we're using is a prior. We're only using prior. Okay, so what is acting like a critical region does not have predictor, but the test statistic, which is the ratio of the probability density function for the two group, is the one that is actually conditioned on predictor. So when that guy is greater or equal to that, okay, we're going to classify object into region 1. But when it is less, the same thing when it is less, you can say this, the two signs must not overlap. If one is greater or equal, the other one will be strictly opposite of that, which is going to be less than. Now, if you take a look at what I have right now, do you know at times there's possibility that if the cause of misclassification are the same, if you take a look at this guy, when the cause are the same, okay, we are going to do the classification through posterior probability. Here, we're not doing the classification through posterior probability. The P1 and the P2 are the prior. The P1 and the P2 are the prior. We're actually going to use this when the cost of classifications for the two groups are not the same. But when they are the same, then we're actually going to use the one that involve posterior and not prior. But what of in a situation, okay, if you take a look at what I just talked about here, okay, when the cost of misclassification are the same, okay, we're actually going to use posterior probability. But what if in a situation where the costs are the same and even the prior probability are the same? For prior probability the same, that will be a balanced data. A balanced data, you go into a bank, you look at the record, 50% of the customers have defaulted before, 50% have not defaulted. That is the situation where the prior are going to be the same. But that is very rare, okay? Because what we normally have in real life is unbalanced data. Now, situation where this occur, of course, mathematically speaking, if all of that is going to cancel out, you know that? All of this is gonna cancel that. This is what I'm talking about. Give me 1 second. When they are all the same, this is gonna cancel out. When that is the same as that, that's gonna cancel out. We're actually gonna left with one. You see that? We're gonna left with one mathematically. Okay, so situation where the prior probability are the same and the cost of classification is the same, then we're actually going to have a new classification rule, which is going to consider the ratio of the two probability density function, okay, greater or equal to 1 or less than 1. Take a look at that. Okay, is there any question? Is there any question? Why do I want to come to multivariate? Why do I want to come to two multivariate normal population? Because the approach that we want to use requires normality of the density of the random variable that I call predator here. It requires normality, okay? And the multivariate because the numbers of predator we're going to have will be more than one. Otherwise, if you want to base your decision on just one predator, you're going to be talking about univariate. So I'm going to talk about multivariate. Now, right now, I want you to take a look at this. It's going to be multivariate because so many features are going to be involved. And the requirement is to have to be multivariate normal. So take a look at that. Okay, X1, S2, S3 up to XP. Maybe I'm talking about the income. I'm talking about the balance on your account. I'm talking about your credit score, so on like that. I got S1, S2 up to XP. And of course, there is this probability density function for the two groups. And that is going to be multivariate normal for the first group, multivariate normal for the second group. Okay, and we want to assign, okay, we actually want to assign to group, okay, observation. Now I need you to pay attention. We've done the one that I showed you the other time was based on univariate. You take a look at what I'm showing you now. How do I write a multivariate normal density? Okay, we've done that in this class. Okay, so this is a multivariate normal density. Now, you see that I put K, right? K here will represent a particular group I'm talking about. Okay, group 1, when K equal to 1, that will be multivariate normality for group 1. When K equal to 2, that's going to be multivariate normality for group 2. And don't forget, what are we going to, what do we want to use? We actually want to do the ratio of the two densities. So in this case, we're going to be doing the ratio of the two multivariate normality. Is there any question here? Oh my God, I'm seeing a lot of final exam questions here. Okay, pay attention. because what I'm going to put on the final exam, so what we're doing lately, we actually take 60% of the final. So, okay, now I want to do the ratio. Plug in 1 for K and plug in 2 for K. You're going to have two form of that. Then perform the algebraic operation of ratio. And at the end of the day, oh my God, when I do that, something is going to cancel out. This aspect is going to cancel out. That particular aspect is going to be considered to be a constant. When I find the ratio, that's going to cancel out. And when I cancel out, I'm only going to have exponential something. I'm going to have something that look at this. Okay? Where then I simplify, and at the end of the day, this is what I'm getting. Take a look at that. After simplification, that is what I'm going to get. And I needed to pay attention to what I'm getting. Mu1 minus mu2, mu1 plus mu2. Look at that. The mu1 is going to be the mean of the first group. The mu2 is going to be the mean of the second group. Now take a look at that. Now don't forget, okay, what we've done here is just the ratio. Okay, we need to compare that with something. Okay, and I said, the R1 and the R2 that will minimize, don't forget the ECM. Okay, oh my God, I'm seeing something now. Why do I have a log F? I'm actually going to, please pay attention. I'm actually going to have a log F because of the exponentiation. When exponentiation, when I take the log of both sides, that is when the exponentiation is going to disappear mathematically. Don't forget, f equal to exponential raised to power that. I want to remove the exponential now. Mathematically speaking, I'm actually going to take the logarithm of both sides. And taking the logarithm of both sides, I'm not going to have f anymore, but I'm going to have a logarithm of f. Okay, so you can look at that, logarithm of f. And when I have a logarithm of f, so now to take a decision now, I'm going to say the log of f have to be greater or equal to the log of that. Okay, don't forget, I gave you this before. Okay, this is a situation where the cause of misclassification is not the same. When the cause of misclassification is not the same, you're actually going to use a prior probability. But when the cause of misclassification are the same, you're going to use posterior probability. But when the cause of the classification is the same and the priors are the same, of course, you're actually going to use something else. Okay. Now, let's look at the classification rule in practice. The classification rule in practice, where you have data set, right? You got data set, okay? You need to find the mean for the first group. Oh, how do we find the mean for the first group? Because the data set and involved is going to be a cap. It's going to be an estimate. It's going to be sample mean. Then you find the means for the second group. Okay. Now let me now tell you this. We want to have an assumption. An assumption is that even though the mean are not the same, assumption is that they have the same covariance structure. When the two groups have the same covariance structure, then we can actually use a combined covariance structure. So what you see here is like a pooled, oh my God, that's a pooled covariance structure. We use a pooled covariance structure on the assumptions of equality of covariance structure, between the two groups. This is when you're working with a sample now. Okay? Now I'm gonna keep on moving. Now you understand how to go about that. Then I'm gonna keep on moving. Okay. Now, please pay attention. Pay attention. At the end of the day, the estimated classification rule will replace F star with a sample estimate as this guy here. Okay, as this guy here. You've already computed, what your X bar, X1 bar is, S2 bar is. You know what your XP. Your XP is a pool covariance structure. Okay. Now you can obtain this particular statistics now. Okay, so take a look at that. Okay, now the classification rule in practice, don't forget, the left side of the aisle is when we consider, when we compute F, which is the ratio, right? Where we and that ratio has been simplified as this. Do you see that? As in simplify as this guy here. Okay. This one is the one for the left hand side. But which one are we going to compare that with? To classify, we want to look at the right hand side. The right hand side is always occupied by the ratio of the misclassification cause and the prior. Now we want to visit the right, the other side of the aisle. Now take a look at that. I'm actually going to call that other side V, which is the ratio of the misclassification cause and the ratio of the prior. And I said they could be equal to 1. The condition on that which is going to be equal to 1 is if the misclassification cause is the same and the prior is going to be the same. Now, if I want to derive a rule, now I'm actually going to say the rule is going to be when y cap is greater or equal to m cap, okay, I will classify observation into region 1 when y cap is greater or equal to m cap, and I will classify observation into region 2, okay, when y cap is less. Now the question is, what is my y cap? Oh, okay. My y cap is a linear combination. You remember in this course, we talk about linear combination, right? Now, it's y cap is a cap x, and m cap is the midpoint of the averages. Okay, where is this guy coming from? Okay, it's actually coming from the derivations that we did the other time. Okay, take a look at this. Here, mu1 plus mu2 over 2. You see mu1 minus mu2. Okay, so right now, so if you come here, you can see that is a y cap, that is the m. So it's going to be so easy to do right now. So this is what I'm comparing with. Okay, this guy is the m cap. This guy is the m cap. Okay, it's very easy to find the average, the midpoint of the two averages. Then here, I need to four of us get the a cap. And the a cap is this guy. Oh my God. Subtracting the mean multiplied by the inverse of a pool covariance structure. Inverse of a pooled covariance structure. Don't forget the XP. Okay, the XP is the pool covariance structure. Then I'm actually going to show you a lot of calculation here. Okay, look at that. This is the SP. Can you see the XP? Okay, can you see the SP? Okay, it means you need to first find the XP, which is the pool covariance structure. Okay, then after you're done with that, okay, then you actually going to you'll be able to get your A cap, then you're going to be able to get your Y cap the moment. And let me tell you this, there's going to be two forms of Y cap, okay, in terms of when you want to talk about the mean. Take a look at this. If Y cap is this, if I'm focusing on the average, I'm going to have the average for the first one, the average for the second one. Okay, I think this is where I'm actually going to stop. We're going to continue with this material. Like I said, for those of you who are interested in improving your grade. Now, let me tell you, our students have been asking me, some students have reached out to me, what kind of makeup is it going to be, makeup for midterm 1 or makeup for midterm 2 that I'm going to post on Friday, because I'm posting that on Friday, and of course, it's going to be due Sunday night. So because I look at the performance in midterm 2 and midterm 1, so I was not satisfied with the performance in midterm 2. So I'm doing midterm 2 first. Midterm 2 makeup. The midterm 2 makeup is actually going to be multiple choice questions. And I think I've said, how many questions? I've said 20. But those 20 questions will revolve around the area for midterm two. You should be ready to work with your calculator. You should be ready because there's going to be a lot of computation where you're going to see questions from confidence interval for one population. The same area that was covered in midterm too. But this time around, the difference is just like the answers are there. You don't need to show any work for me. Just pick your option, the best option, and the moment you submit, you will receive your grade immediately because it's already programmed. So I need you to make use of that opportunity. Somebody who believe in second chance, because I know at times students have a lot of let me just say complicated or conflicting schedule, and maybe that is the reason why they don't perform well in the first place. And that's why I'm giving another opportunity. So I will advise that you spend your time on me-time solutions that are uploaded, because that was the reason why I decided not to post new assignments for this class this week, so that you'll be able to have more room to prepare for the makeup. And this is going to be the deal. This is going to be the deal. I'm not going to use 70%, 30%. I will choose out of the original midterm two and the midterm two makeup the one you score the highest. So which means if somebody perform poorly in the makeup, is still going to have his original grade. You understand what I mean? But my intention is for you to improve on your grade. Imagine somebody scored 80 before and somebody now score 100%. I'm going to delete the 80%. I'm going to substitute that for 100%. That makes sense? Okay. Make sure you all stay safe. See you on Friday. Bye for now, everyone.